Hello and welcome everybody to Advent of Code 2023 Day 9. So today was a pretty fun one. It was very straightforward and is also one of the kind of rare cases where your part 1 code and part 2 code are should be practically identical. At least mine were anyway. There was only very subtle change between the two puzzles. Effectively, the difference between the part 1 and part 2 is they asked you to do something and then they asked you to do it in reverse. So as long as you've written your code in a pretty straightforward way, you should be able to flip it around without really any trouble. They might have caught a few people out maybe, but really materially there's very little difference it will actually make to the whole algorithm. So with that said, let's jump in, talk about the problem, and look at some code. So we've got day 9, Mirage maintenance. So we're riding on our camel. We've gotten through the sandstorm, and it's stopped. And we're now at an oasis. So you're looking around and you see that there's another island that you want to go to, which is all metal apparently, and you reckon that that's where the parts that you need to fix the sand machine are, that you need to then filter the water that you need to make the snow. So you see a hang glider that's partially buried in the sand, and you think that once the sun rises and the sand heats up the sand, you might be able to use the glider to fly up on the hot air to this island. In the meantime, you decide that while you're around this oasis, you're going to have a look and do some ecological surveying of this oasis. So you pull out your handy oasis and sand instability sensor, and you start looking at your surroundings, which is your puzzle input. So this is our puzzle input here. It's a list of values. So what you're told is basically that each of these values, they sort of increase in some pattern. And what our job is to do is to figure out what the pattern of the increase is and determine what the next number should be for each line. And the answer will be the sum of each of those next values for the whole input. So we're told, so at first when you look at that, you might be reading it thinking, well, how the hell am I going to solve that problem? But they actually give you the pattern, or they give you the method to use to solve the pattern, basically. So if you come down here, this is basically how they tell you to solve it. So what you're supposed to do is you're supposed to look at the difference between each of the pairs of values as they increase. And from that difference between each pair, you're supposed to generate another list of values. So what you're supposed to do is you're supposed to do this until you arrive at this thing here, which is basically where you've got all the values are the same. So that means that when you try and get the differences between all of these, you'll get this list of all zeros. And once you've gotten that, you know you're at basically the bottom of this sort of iteration. And your answer should be you basically add 1 onto the ends of each of these, and you walk back up your tree again and you add on to the end, and that should give you your next answer. So if we go down to a fleshed out version, down here. So we've discovered our pattern, which goes down to here. So we've got 0, 3, 6, 9, 12, 15. We've determined that this is, all threes the whole way along here. So what we do is we add 1 more to the end of this. So we so we take 0 plus 3 is 3, and then 3 plus 15 is 18. So you just take the last one, you add a new one on. Once you've gotten to the very bottom, you add a new one on, and you add it to the last one each time, and you just go up the chain again, and then add that to the end, and that's your answer. And you see this is just a bigger example down here. So the pattern here, as you look at it, isn't necessarily as obvious. But you see the difference between here is 2, difference between here is 3, 4, 5, 6. Then we've got, we can see that the difference between all of these is all 1s. And then we've got 0. And so then if you go back up the chain again, you get 0, 1, 7, and 28, which is just adding to the previous one to get the next one. And that's it. So that's basically what we're doing here. And And yeah, this is just the last example. See, it goes deeper again. And then at the end, we sum together all those final values we found, and we get 114 for the answer for the sample. So this seems a bit odd, and it kind of is a little strange. But like effectively what you're actually doing here. So the code, there's not a huge amount of code to show here, but one thing, if you think through this algorithm, what you're actually doing is it's sort of doing derivatives in the sense of like calculus, which looks at rates of change of things, or that's the way you can think about it. So each layer down you're going is sort of like a next order of a derivative. So it's a rate of change of a rate of change, basically. So if you thought about it as like speed and acceleration, we've got like, well, these are like our speeds. And then this is, well, these are the differences in the speeds. So the differences in the speeds is going to be, the next one down is going to be the accelerations. And then you're kind of going down and down and down and down all the way to some higher order kind of derivatives. That's sort of a way you can think about it. Like, that might not necessarily be something that is intuitive to you or whatever if you don't know the maths, but it's just kind of a sort of an observation I made about it. But yeah, ultimately it doesn't change what your answer is going to be or what the how the puzzle works or anything like that. So, it won't necessarily, knowing that won't necessarily help you to solve this. It's just an observation about this is what's kind of what you're modeling basically with this problem. Cool. Okay, so with that said, let's have a look at the code. So this is our code for the solution, and it is, I think, of actual code, non-boilerplate. There's like 6 lines, 7 lines of actual code, which is quite straightforward. So I chose to do this with a recursive algorithm. So far, this is actually the first recursive algorithm I've used in this. I tend to use them quite a lot in these puzzles because certain types of problems tend to lend themselves quite well to a recursive algorithm, especially if you're doing stuff to do with like graphs and like traversing graphs and stuff like that. Recursion works quite well. And this instance, because you're basically sort of nesting lower and lower, and what you do at each level of that, tree that we saw is the exact same operation. That jumped to me immediately to be a good case to use recursion for this. So effectively what we have done here is, well, I'll set up an array for the values. So this is just going to be our last value for each one. We're going to loop through our input file, and we're going to pass in an array that represents our string of numbers per line. What this will do, this algorithm, once it finishes, it'll spit out what the next, like, last value should be. And then at the very end, we just sum those all together, and that gives us our answer. So the recursive function then, down here, it just accepts a single input, which is the array of our numbers. What we do when we first enter this is we determine what the new array is going to be. So this is basically what the second level down is, which is going to be our differences. So it's always an array of a length 1 less than what our input was, because it's the differences between all the pairs. So we calculate that here. This Ruby function just gives you a chunked up array of each pair of values as you go along. So I pass that to a map function, subtract the two values to get the difference between them, and then that just gives me a new array that is all just the differences, and it'll be shorter than the original array. Then as we go down, so the next thing we want to do is we want to see, well, have we arrived at a point where all of those values are the same and that they're all 0? So I take the input that's come in. I have a look and see, are they all the same value? Is the value 0? If so, then I'm just going to return the last value that I calculated in the thing, which when you get basically to the bottom, you're going to be returning 0. So that's your end condition will be returning 0, and then this will bubble all the way up, and it'll be returning the last value plus the sum of the other one, which is what we do down here. So if this isn't the case, if we're not at the bottom, then we go and we say, okay, well, I'm going to return the last value that I have from my input, and I'm going to add it to the next difference that's calculated here, which we pass in the new input for that. And that's it. So this will iterate all the way down through, and then when it gets to the bottom, which is all the 0 case, it'll return 0, and then you go to the next one, it'll return 0 plus whatever, 2 or 3, 5, whatever, doesn't matter, and then it'll be that one plus the last one, that one plus the last one, all the way up to the top until it eventually just spits out a single number, which is the next in the sequence. And yeah, that's it. It's recursive algorithms can be a little bit difficult to think through and to talk about, but that is effectively what we're doing. We're trying to iterate all the way down through these till we get to all the zeros. Then we start at them as we go back up the chain of the returns. We're just adding on the last value each time until we get to the end. So we can run that 9 1 on the sample. And that's our answer, and it's relatively quick. And then we can run it for our input, and that is also very quick. And that is the answer. So yeah, let's move on to part 2. So part 2, like I said earlier, they basically just say to do it in reverse. So they give you the same thing. They say, well, okay, now you can extrapolate backwards instead of just going forwards to get the values. And they give you an example here where they've done it backwards. And yeah, it gives you the answer for that one they gave is like 5, which was, we saw up here, that last one, when we went this way, it ended up at 68. So we take the same thing and we do it backwards, and we'll say, well, the start was 5 then. So this isn't not terribly difficult to do. You look at it and you go, okay, obviously I'm doing roughly the same thing but backwards. But then the difference in the code is almost negligible. So if I just quickly flick between these two, you'll see there's very, very little has changed. So the way I did it was I took the input sequence and I flipped it around. So just reverse it here with this reverse function. And then in the recursive algorithm, the only difference that I did was, instead of subtracting so when you split up our pairs, instead of taking the second value and subtracting the first one, I just flip it the other way around, which will give me the opposite direction of difference. And that's it. And it gives the right answers. So we can run part 2 on the sample, and yep, and then we can run it on the input, and that is the correct answer. And it runs in nearly the exact same time, because it's basically doing the exact same thing, just the other way around. So yeah, that's basically it. Now the only other thing that is probably worth saying in this is that the case for this, where I chose to use recursion for it, made sense to me for a number of reasons. And it's probably worth, if I'll throw up the input here, my input file, because sometimes we talk about these things and see that, well, the difference, if you were to look at the sample and then think about, well, looking at the input, and then you're thinking about the difference between them. And sometimes what I mentioned before is that, well, when you look at the sample, the numbers are such that a naive solution, or like a brute force looping solution, would appear to work. But then when you try it on the real thing, it's like, well, you look at the numbers and the numbers are way too big and it just will never work. So if you were to apply that same logic to look at this input, you may think that same case applies here. But the trick is that it's not just about the size of the numbers. You also have to understand the context of what those numbers mean. So in this instance, the amount of recursions down that you have to go in the stack isn't to do with how big the numbers are. The size of the numbers is only going to affect the arithmetic based on the arithmetic of use your words, Ian. The arithmetic just for those subtractions and those additions. It's just subtraction, sorry. So that's not going to affect it. What's going to affect how deep you're going in the recursions basically is the differences between the values. So what I mean is that the number of iterations down is basically based on the length of the input, because the length of the input will decide how many times you can get a difference between its pairs, right? So if you've got a distance between its pairs, you know that the next iteration down will be one less what it was before, and then one less what it was before. So if you look at these inputs, there's only, it's quite a short array, so you're very much limited in how deep those iterations are actually going to go in the algorithm. So that's a good pointer as well for something that's good for recursion. So recursion can have the issue where it'll basically just run forever, and then you don't know when you've reached the boundary condition. You're not sure, is this just running, am I caught in an infinite loop, or have I just not reached the bottom yet? And in this case, you know that, well, I should reach the bottom because I know there's a limit to how far down I can go. So that's one of these things where it's like, that's a good hint that, okay, if I just try and do like a looping recursive function here, I'm not going to just explode off to infinity. So if I do end up with it running to infinity, I know I've just done something wrong in my code probably. And yeah, big numbers here. You see these big numbers, they could be scary, but they're actually not going to be. It's not really material to the question. So yeah, that's day 9 down. It was a pretty fun one. Didn't take very long, and yeah, it's kind of interesting. Just some interesting things to think about with it. One thing I'm excited to see is I'm going to go and have a look on Reddit and see other people's solutions and see how many people have a really succinct one-liner to do this whole thing. I always love seeing those. I never tried to do them myself, but I'm always fascinated to see what people can do with a single line of code. So yeah, that's it for today. Thanks for watching, folks, and I will see you all tomorrow. Bye-bye.